So one thing that we did leave out, which I did not mention in this case, if I had this being adult and this being student, it really wouldn't matter at all if we flip-flop them. The lines might adjust a bit, but it really wouldn't matter at all in that case. So we wouldn't have any major change. But the cool part about it is you can see that right in here, we do in fact see our solution. You can see right here, this little spot right there, that's where the lines cross. And if you recall, that looks like 30 and 20. So that was the solution that we found out earlier on the previous page that would satisfy both equations. So you can see how drawing the graphs where it crosses, that's where we would get our answer as well. All right, B2. Determine the coordinates of the intersection point. Explain what the coordinates tell you about the numbers of adult and student memberships. Told, well, we already know that is our ordered pair, but if I have B2 here, so you can see that's gonna be at 30 and 20. So 30, 20 is the ordered pair. What that stands for is 30 adult memberships plus the 20 student memberships all that's gonna end up equaling the $400. But it also, that's the key phrase here, also it represents the 30 adults plus the 20 students that equaled the 50 memberships. So you see how when it comes to these things, this is a system of equations where these two different situations in one situation allowed us to figure out the information about how many people signed up. B3, could there be a common solution for the two equations that is not shown on your graph? Meaning, could there be another situation where both of these equations would be satisfied? If you look at our graph, if we continue these on forever, the dark blue one going down here, it's going to get further and further down here, further up there, and then the light blue one, there would be no other place that they would cross. So in this case, the question says, could there be one? No, there's not going to be another one. This is the only solution where the situation works, to have $400 made and 50 people participate in membership. All right, B4. Describe situations you have studied in previous units that are similar to this problem. Well, honestly, off the top of my head, the one situation I remember from the past that we talked about two scenarios where lines would cross was back in the moving straight ahead situation with Henri and Emile and the walking race. Remember the big brother wanted to give a little bit of a head start so they would make it a close race. We knew how long the race had to be so it would be close, and so as the lines crossed, we figured out that that would end up being a little bit shorter than that. That's another example of systems of equations that you guys have already were aware of. So that's something that has been popping up periodically throughout our work, but now we're really actually identifying it as a system of equations. All right, so it says here, the two equations you wrote to model the conditions of this problem are called a system of linear equations. The coordinates of the intersection point satisfy both equations. These coordinates are the solution of the system. So in this case, whenever we have two equations that are a part of a certain situation, they are a system, but the answer is the solution of the system, not just the regular old answer, it's a solution of the system. All right, part C. It says use graphic or symbolic methods to solve each system of linear equations. Check your answer. Okay, so we got 4 more different situations with each of these, and so what I think I'm gonna do is I'm gonna choose 2 of them to do symbolically, which would be with algebra, and 2 of them to do through making a graph. And so we'll do that now. All right, C1, x plus y equals 4, and x minus y equals -2. Well, let's come up with some ordered pair options here first for this one. So I'll do x and y. So I know if I put 0, it's gonna be 4. If I put 1, it's gonna be 3. If I put 2, it's gonna be 2. If I put 3, it's gonna be 1. And if I put 4, it's gonna be 0. Those are the only ones that I could really work with at this point that are gonna add up to 0. Now we could do others, we could get some negative numbers. Let's just work with these guys for right now. So what I need to do though is take these values and plug them in to see if I actually get -2. So to do this here, I'm gonna take each of these guys and plug them in. All right, I realized I made a mistake. We're gonna start over here. So I'm gonna put both of these guys in here. So if I get, for this first part, 0 minus 4, what would that equal? That would equal -4. So that doesn't work here. So that one's not gonna work. Let's try this one. If I put 1 in here now, 1 minus 3, hey, look at that, equals -2. So it turns out that this is the solution in this case. The ordered pair for this case would be 1 and 3. That's one way to do that. All right, number 2. 2x plus y equals -1, and x minus 2y equals 7. So first of all, I'm gonna work over here, and I always wanna start off just getting some basic ideas. Let's just put in some numbers and work with it, see what we can come up with. So I'm gonna put 0 in here for this. So if I put 0 in for this, 2 times 0 is gonna be 0, so it's gone. I'm left with y equals -1, right? You see how that's automatically gonna be that? So I'm gonna get -1 here. So that's one that fits over here. Let's put 1 in this case over here. So if I put 1 in here, so it'd be 2 times 1 would be 2 plus y equals -1. If I do -2, that would mean y would equal -3. Okay, so -3 would be another solution in that case. Let's try putting in 2. So 2 times 2 would be 4 plus y equals -1. -4, this is going to be gone. Y would equal -5. Okay, so -5. So let's see if we have enough there. Let's try to work with these, see what we can come up with. So let's just going to start putting these in. So if I put 0 in here and -1 in here, am I going to get 7? So 0 minus 2 times -1 would be a -2, which makes this a +2. Does that equal 7? No, it doesn't work. All right, so let's put 1 in here now. So 1 minus, that's going to be a -2 times -3 is going to be +6. Hey, look at that. That checks. So our solution is going to be 1, -3. So that's that. All right, so in this case, for number 3, we have -2x plus y equals 3 and -4x plus 2y equals 6. Now, I don't know if any of you catch anything unique about it beforehand, but I'm actually going to do a little bit of a unique approach. I'm going to review some of that work we did yesterday with moving these into slope-intercept form to see if we can find something out before we graph them, because graphing them in slope-intercept form is much simpler. So in this case, what I'm going to do is I'm just going to move this 2x over, so it'll be plus 2x here, plus 2x here. So I'd have y is equal to 2x plus 3. All right, so that equation is ready to go in slope-intercept form. So I can go ahead and graph that one as well. Let me find my ruler. So we'll draw this in. And hopefully you remember, I got ink on my desk. Oh no. Hopefully you remember when we put these on here, we go to y-intercept first, so up 3, put a dot. Our slope is going to be a 2/1, so up 2/1. So there is our graph, just like that. So this represents y equals 2x plus 3. All right, now on for this one. Same process. I'm going to need to move this over here, so I'm going to do plus 4x and plus 4x. This is gone. 2y is equal to 4x plus 6. All right, divide by 2, divide by 2, divide by 2. This is going to be y equals, 2x plus 3. Hey, we got the exact same equations. If I graph this, it would be the exactly same situation. So what that means is, if you recall, that our answers are all numbers, or we might say infinitely, I can spell it, many. Infinitely many. Okay, part C. -2x plus y equals 3 and -4x plus 2y equals 10. Now, interesting, this is the equation we just had from the last one. So I'm going to actually go ahead and put it back in that same form, if you recall. Plus 2x plus 2x, y equals 2x plus 3. And we did, in fact, graph that as well. So I'm going to graph this again, nice and quick. So we got our plus 3 and our up 2/1, and that's that's here. And this is y equals 2x plus 3. All right. So now, same work we have to do over here. Let's move this around and simplify this a bit. So plus 4x plus 4x. I'm going to be left with 2y equals 4x plus 10. Divided by 2, divided by 2, divided by 2. I've got y equals 2x plus 5. Okay, cool. So not the same equation, but the same slope. So this is going to be interesting. Let's see what this does here. So if I'm going to graph this with a different color, so you can see we have our y-intercept is 5. So here's 3 and 4 and 5. So there's the y-intercept there. And our y-intercept is still 2, so up 2 over 1. So when I graph this, look at these guys are going to be parallel because they have the exact same slope. These lines will never cross. So that means no solution, or we would do that. All right, guys. So lots of review in there, kind of pulling together the pieces to show the systems of two of those equations would work. Don't forget about the information about no solution and infinitely many or all numbers that pops up. But we have, for tonight's ACE work, or today's ACE work, I should say, we're going to be working on numbers 22 through 27. So let's take a look. All right, here goes. Tell which line below is the graph of each equation in parts A through D, and explain. So you've got A, B, C, D. You've got line K, L, M, and N. You're going to match them up to see which one goes with which one, and how you know which one goes with that. Okay. 23. Exercise 1. Suppose the goal is to raise $600. One equation relating the calendar and poster sales to the $600 goal is 3C plus 2P equals 600. Suppose the company is donating calendars and posters. So it is C calendars, P posters. They said would provide a total of 250 items. What equation relates C and P to the 250 items donated? Graph both equations on the same grid. Find the coordinates of the intersection point. Explain how these coordinates tell you about the fundraising situation. All right. 24. In exercise 2, one equation relating Kateri's quarters and dimes to her goal, $10 is 1,000 cents, is 25x plus 10y equals 1,000. Suppose Kateri collects 70 coins to reach her goal. So this goes back to number 2. So make sure we check on that one here. Okay, so this is her work about coins getting the $10. Hopefully you remember that one. Okay. So it says here, graph both of those equations, find those coordinates on the intersection point, explain what those coordinates tell you about the situation. Exercise 3, one equation relating the times Eric spends running and walking to reach the goal of covering 1,600 meters is 200x plus 80y equals 1,600. Suppose Eric runs and walks for a total of 12 minutes to reach his goal. What equation relates x and y to Eric's total time? Graph both those equations on the same grid. 26, in exercise 4, one equation relating the ages of Kevin and his mother is y minus 3x equals 1. The sum of Kevin's age and his mother's ages is 61 years. The sum, that's interesting, we go back to the sum. So you have Kevin and his mom equal 61. So what equation would be there? Kind of just told you. And you have the graph of those situations there too. And lastly for 27, using graphing methods to solve each system of equations. Use your graphing calculator, or you can determine that situation, whatever you need to do. But you're going to go ahead and graph these guys like we did as well to find those pieces. Okay. All right, let's give it a go. Hopefully this will be helpful. Take a look at those videos, give them a watch, and we'll catch you next time. All right, take care, you guys.